Greeting. Below I will explain the article that is titled Thermal Conductivity of Hybrid Recycled Aggregate Rubberized Concrete Equilibrium of the Magazine Construction and Building Materials of the year 2016 and the editorial Elsevier. The article is a laboratory study that examined the validity of incorporating different quantities of recycled concrete with aggregates, now by acronym RCA, and rubber chrome scaled RI to create a hybrid recycled aggregate concrete stick RRC, which offered certain physical and mechanical properties. Thermal conductivity studies were conducted to eliminate the effect of thin natural aggregates Na, with a result that the maximum thermal conductivity of a concrete sample containing smooth cement was 1.186 watt per meter Kelvin. Minerals and methods. The key properties of a variety of different rubber concrete mixtures incorporating recycled aggregates are investigated. These are limited to include drop test, density, compress resistance, water absorption, and thermal conductivity of an RRC concrete that is prepared with the addition of different percent types of aggregate were prepared for use in the study. 1. Natural thick aggregates, specifically crushed limestone, which mentions the items that were obtained locally to obtain the control concrete mixture. The rating of thick natural aggregates, Na, was shown in the figure 1 within standard limits. 2. RCA, recycled concrete with aggregates, was obtained by crushing previous tested concrete samples with a compression resistance equal to 27 megapascals. The obtained particles were weighed, dried and sifted using standard aggregate sieves. The grading curve is shown in the figure 1. 3. The fine aggregate is natural silica sand with gradation as shown in figure 2. 4. The rubber chrome was obtained from a local industrial unit in Jordan. This rubber chrome was nominal in size between 4.75 mm and 0.075 mm. It will be used to replace 0.20% of fine aggregate by volume. The gradient curves for fine aggregates and rubber chrome are shown in figure 2. The size of the rubber or rubber chrome compared to the size of sand is shown in figure 3. The cement used in all mixture is ordinary Portland cement according to HTM C150-92 Type 1 specifications. The photographic microscope has been used to determine the uniformity of the ingredients within the mixtures. The size of the particle that allows optical identification in these microscopes is not less than 0.010 mm. A sample of a slice was cut the photographic analysis. The results were obtained. Density. Generally, the density of concrete varies depending on the aggregate density, the trapped air, the water cement ratio, and the maximum size of the aggregate. The results of blend density are shown in Table 2. Due to specific law of rubber crop particles, the unit weight of rubber concrete decreases as the percent of rubber crop replaced increases. Density decreased from 2,399 kg per cubic meter of smooth concrete to 2,009 kg per cubic meter for RRC with 20% RCA. A reduction of 16.26% from conventional mixing. Water absorption. Results indicate that water absorption increased because it has a higher percent of RA. The trend of water absorption results shown in figure 9, showing that for concrete with aggregates is quite similar to that observed with RI replacement up to 20%. A similar trend was found for RRC, where water absorption increased as it had a higher percent of RRC air. The average of 3 compression resistant cubes for each mixture is shown in Table 3. The percent reduction in the compression resistance of concrete incorporating 20% RCA was 18% over the reference mixture. The percent reduction in the compression resistance of rubber concrete compared to conventional concrete was found to be 19.5% for the replacement of 10% of air. Thermal conductivity findings show that thermal conductivity values decrease when the amount of RCA increases. The results obtained for thermal conductivity are within a range of 1.25 watt per meter grade Celsius for conventional concrete and 0.79 watt per meter grade Celsius for 20% with ARC. Referring to the analysis of the optical photos of the cement matrix containing rubber particles with % magnification, good cohesion is found between the RCA particles and the cement matrix except for the air vacuums in the rubber cement interface as shown in figure 15. Signs: the air has a thermal conductivity of 0.0026 watt per meter Kelvin that help improve the thermal insulation property for the mixture. Visual inspection of the test samples confirming several types of errors that are easily identifiable as macro cracks, identified as combination of aggregate and paste leaking failure, thick aggregate failure, RCA failure, and RCA paste error, as is shown in figure 16. Conclusion: it is found that while RCA generally reduces resistance to concrete compression due to increased aggregate water absorption and weak residual mortar layer, it is possible to produce RRC with improved thermal insulation property due to its lower thermal insulation conductivity on conventional concrete.